Hello, I'm Cornez Rubat, and in the next video series I would like to introduce my measurement program development framework called Optens. But first, I would like to introduce myself a little. I have been working in an EMS manufacturing environment since 2008, especially in the world of electronic testing. I started as a maintenance worker, then I was a technician for a few years, and I have been working as a test engineer since 2014. I also graduated with a degree in computer science this year. Over the years, I have carried out many small developments for which I used LabVIEW, Java, and Python. The disadvantage of these was that either the project became expensive due to the licenses, or the development took a long time because everything always had to be written from scratch. That's why in 2019, I decided to develop a test program framework in Python, with which I could create test programs simply, quickly, and for free. Since then, my system has been used in many projects. However, over time I had to realize that there was a lot to improve, and a much better framework could be built if I rebuilt the whole thing from the ground up. So, using my 18 years of testing experience and the lessons, advantages, and disadvantages of my previous system, I refactored the entire program from scratch this year, in my free time at home, and extended it with several new, useful features. In this video series, I would like to introduce this new framework. First, let's take a look at what Optens actually means. It is an acronym made up of the first letters of the words Open Test Engine System. As its name suggests, this is a system whose engine is optimized for testing tasks, instrument control, report file generation, and use in a production environment. The system consists of two main applications. The first one is the Optens Editor, and the second one is the Optens Runner. As their names suggest, the editor is where you can create and edit test programs. It is, so to speak, the test engineer's interface. The runner, on the other hand, provides a clean, simple user interface for the operators working on the production floor. Now let's review the structure and main functions of the editor program. When we start the program, a window appears for the duration of the loading, where the loading process can be monitored. After this, the actual editor window appears. This is an editing program where the steps of the measurement program are grouped in separate subprograms, and the step sequences of the subprograms are displayed in a table. The properties and parameters of the steps can also be set on a graphical interface. But let's review the detailed structure of the program. At the top of the program window, you will find the menu bar, where various file operations, program editing, and program execution functions are available. Under the File menu, you will find the usual file operations, such as creating a new program, opening an existing one, saving the program currently being edited, or saving it as a new file, viewing the version history of the open program, exiting the application. The File menu also contains a special submenu, and that is the Program list. This submenu contains the programs saved as projects grouped by customer. By hovering the mouse over a customer's name, the list of test programs associated with that customer will appear as well. Clicking on one of these programs will load that program. The programs shown here can also be loaded in the Runner application, that is, in the operator interface as well. This differs from a simple file open in that when opened from here, a configuration file is automatically loaded along with the program. And in the case of the operator interface, the product image and reporting settings are also applied. But we will talk about that later. Next to the File menu, you will find the Edit menu. Currently, this is where the Program List Editor function is accessible, which allows you to edit the list of programs found in the File menu. But we will discuss this in detail later. From the Insert menu, steps can be inserted into the subprograms. Here, the steps are grouped by function category. For example, there are conversion operations, device and port-related operations, file operations, mathematical operations, and many more. Hovering the mouse over one of these categories will reveal the list of steps within that category. For example, if we hover over the string menu item, we can see that there is one that checks for the presence of a substring within a string, one that counts the number of occurrences of a specific character, one that counts the length of a string, one that converts text to uppercase or lowercase, and one that replaces a part of it. At the bottom of the Insert menu, you will find Reload Modules. Clicking this causes the framework to reload the list of modules and functions. This is particularly useful when we are editing a new step type for our system and do not want to reopen the entire framework. Yes, you heard that right. The functions of the framework can be easily extended according to the specific testing task at hand. All you need to do is write the module for the given function, place it in the appropriate folder of the system, and it can already be inserted into the test program. And from that point on, this module will be available for use in any new test program. In the Execute menu, you can control the execution of the test program and set the run mode. There are 3 modes. Normal. The test program runs all the way through without stopping anywhere. Breakpoint. The test program only stops at steps where a breakpoint has been set. Step by step. The test program can only be advanced one step at a time, stopping at every step. As for the controls, the following are available. Run. Used to start the measurement. Stop. Used to stop the measurement. Next. When program execution stops at a step, for example, due to a breakpoint, or because it is running in step-by-step mode, clicking this advances the program to the next step. Below the menu bar sits the Toolbar. Here, the most important functions found in the menu bar are directly accessible. These include, for example, starting, stepping, and stopping the test program, creating a new file, opening a file, and saving a file. The program run mode can also be set from here. Below the toolbar, you can find the structure of the test program itself. On the right side, the variables are listed. These are global variables, meaning they are accessible from any point in the test program. If we scroll down the list, we can notice that there are both yellow and white colored variables. The yellow ones currently have no value, while the white ones do have a value assigned. The yellow variables are created within the program and receive their value when the program runs. The white variables represent the variables stored in the configuration file associated with the test program. Every variable has a name, which can be used to reference it, and a value. Next to the variable list, you will find the list of subprograms and cycles. You can switch between the two using this tab. Both subprograms and cycles are sequences of steps. The difference between them lies in how they are called. A subprogram is called once, and the condition for this is the evaluation of a general precondition, in the same way as for a simple step. A cycle, on the other hand, is called multiple times in succession, and how long it keeps repeating depends on a condition system that is independent of the precondition value. This condition is evaluated before or after each iteration, depending on whether it is a pre-test or post-test cycle. Both an if structure and a while loop can be implemented using a cycle. Among the subprograms, there are 2 special ones that are automatically created in every new program and cannot be deleted. These are the main and the cleanup subprograms. The main subprogram is important because when a measurement is started, program execution begins at the top of this subprogram. The cleanup subprogram is important because the steps placed here will always run at the end of execution. This is where you can place tasks such as turning off power supplies, releasing fixtures, resetting relays, and so on. To the left of the subprogram and cycle list, sits this large table-like surface which displays the list of steps of the selected subprogram or cycle. Let's switch to the numeric_test subprogram, for example, to see its steps. By default, this table consists of 7 columns. The columns, from left to right, display the following information. The first column shows the sequential number of the step within the given subprogram. This column has an extra function as well. If we click on a row number, a red dot appears in place of the number. This red dot indicates that a breakpoint has been set at that step, meaning program execution will stop at that step in the editor. Clicking the cell again switches the red dot back to a number, removing the breakpoint. The second column shows the enabled setting. This is used to set whether the given step will run or be in a skipped state. If the cell shows a green check mark, it means the step is not skipped. If the check mark and the entire row are gray, the step is skipped and will not run in either the editor or the runner. This setting can be configured on the General tab of the Properties panel. The third column is either empty or contains a flag icon. The flag means that the execution of that step is tied to a precondition. This precondition can be set on the Precondition tab of the Properties panel, but the precondition editor can also be brought up by clicking on the cell in the third column for that step. If there is no flag, the step's execution is not tied to any condition. The fourth column displays a small icon that is different for each step type, providing a visual aid for identifying the type and function of the step. The fifth column contains the name of the step. This can be freely edited and can be modified on the General tab of the Properties panel. The sixth column contains the step type, the name of the module and function used by the step. This cannot be modified. The seventh column displays the return value of the function used in the given step, provided that the return value has been assigned to a variable. This variable can be a brand new one or one created in a previous step. The variable does not need to be created or defined separately. As soon as it is specified as a return value and does not yet exist, the system creates it automatically. Variables are always stored as strings, and the function that wants to use them will convert the value to whatever type it needs. There is also an extra column that can be enabled manually. To do this, click the Debug View button on the toolbar and switch it to the On state. This reveals an eighth column called Status, which displays the state of each step during execution. The possible states are Pass, Fail, Done, Skip, and Error. Below the step table sits the Properties panel, where the properties of the selected step are displayed. This panel has 4 tabs. The first tab is called General. This tab contains the general properties of the step, such as the step name. Any name can be entered here, and multiple steps can share the same name, since the system references steps in the background using a unique code that is not visible to us. Below the step name is the Enabled checkbox, which sets whether the step is skipped or available to run. Below that is the Breakpoint checkbox, which determines whether execution should stop at that step when running in the editor. Below this, the step type is displayed. At the very bottom, a comment field has been placed, where you can write a note describing what the given step does and what its purpose is. The second tab is called Parameters. This tab is where the input parameters and the return value of the given step can be specified. A step or function can have any number of input parameters, but it can only have one return value. This return value, if we wish to use it later, can be stored in a variable. Variables are always created automatically here and do not need to be defined in advance. An input parameter can be either a fixed value or a variable that was previously created as the result of a step, or a variable from the configuration file associated with the program. The parameters are displayed in a table that is always populated dynamically, depending on the type of the given step. The parameter table has 3 columns. The first is the parameter name, which is fixed text derived from the module that implements the function. The second is the parameter value, which we provide ourselves. It can be either a fixed value or the name of a variable. If we are referencing a variable, the $sign must be placed before the variable name. This tells the system that it should pass the value stored in the variable with that name to the function. The third column is the description, which serves as a help text for the given parameter. This is also derived from the module that implements the function. The third tab is called Precondition. On this tab, a condition system can be built to determine whether the given step should run during measurement or not. If the conditions are met, the step will be executed. If the conditions are not met, the step will be skipped. To bring up the editor interface, you need to either click the Edit button on the tab or click on the cell in the third column of the step table. This window will then appear. At the top of the window, it states which step's precondition is currently being edited. The green block is the outermost block of the condition system. Inside it, additional blocks or steps and variables can be placed. The relationship between these can be either AND or OR. Any number of variables and steps can be connected together, and the blocks can be nested to any depth. Each block acts as a pair of parentheses. Every block and every step or variable condition can also be deleted. The condition system is also expressed in mathematical notation in this summary field. The fourth tab is the Help tab, where the full description and help text of the function and module used in the step is available. There is a general description of what the function does. Below that, the input parameters are listed along with the purpose of each one. At the very bottom, the return value is described, explaining what the module returns. The help text shown on the Parameters tab also pulls its information from here. In the lower right section of the editor, there are 2 more interface elements. And these are the log and the AI assistant. On the log panel, you can follow what operations have taken place since the editor was opened, what steps have been inserted or deleted, when the program was opened or saved, and so on. This is not the test program's history. It is only visible until the editor is closed. The AI assistant is still under development. At the moment, it functions purely as a help tool, from which you can request information about how the system works and how to use it. However, there are plans for it to be able to provide information about the test program currently being edited, and potentially even insert steps into the program based on plain text instructions. But these are still just plans. And with that, we have reached the end of this video, in which we took a general look at the structure and operation of the editor. In the next video, we will go through the runner, the application that provides the operator interface.